Here is the solution for the third problem on our worksheet on rational inequalities. Solve 5 times x minus 1 times x plus 4 divided by x squared times x minus 3 less than equal to 0, right? So whenever you have an inequality like this, first step is to write down the restrictions, right? They will never be in your solution set. So the restriction here is that x is not equal to 0, but that will make it 1 over something over 0, which is undefined, and x is not equal to plus 3, right? So these are the two restrictions which should not appear in your solution set, correct? Now you'll note that this function we have already given you in a form of a rational function, right? And it is factored form. So it's kind of easy. The one part is already done for you. That is factoring and all. Sometimes you may need to factor numerator and denominator to bring it to this form, right? So here I'm going to teach you the method. The method is when you are given a rational function, how to figure out the regions where it is less than 0 or equal to 0 or greater than 0, okay? So we'll try to do that. Now let's try to analyze this rational function. So here, where are our zeros? Let's look at the zeros first. So zeros are at x equals to 1 and x equals to minus 4. Zeros are at x equals to 1 and at x equals to minus 4. Okay. And where are our vertical asymptotes? We say vertical asymptotes are at x equals to 0 and at x equals to 3, right? These are also our restrictions. So these are our vertical asymptotes. Now, if you see the graph of this function, then these zeros and vertical asymptotes are actually going to divide the graph, divide the coordinate plane into different regions, right? So those regions are the regions which need to be tested for being positive or negative. We are interested in those which are negative, right? So let's draw some lines here, and what we will do is these lines will represent our zeros and vertical asymptotes. I'll show you how, and we'll make kind of a table. So it's a combination of showing you a table within a coordinate plane, right? Think like that. So we'll arrange all these. So we got a 0 at minus 4. So we say, well, this is x equals to minus 4, and we have a 0 here, okay? And then we have a vertical asymptote at x equals to 0. Say, well, this is x equals to 0, and we have a vertical asymptote. That means it is not in our domain, okay? And then we have a 0 at 1. So we have a 0 at x equals to 1, and then at minus 4, we already took that. X equals to 3, we have a vertical asymptote. So we have this, and we have a vertical asymptote at x equals to 3, right? So these holes are showing vertical asymptotes for me. Let me write this with this vertical asymptotes, and these dots here are showing zeros for me, okay? That is a vertical asymptote, and these are my zeros. Now at zeros, the graph is going to cross the x-intercept. So when it crosses it, it may change from negative to positive or from positive to negative, right? That's why we are checking these regions. Vertical asymptotes are discontinuities, so the graph has to start all over again. So, you know, it may be going positive, but it can start from negative. That is the reason why we are checking our plane, which is divided by these zeros and vertical asymptotes, correct? Now, so what are the regions? So when we say this is minus 4, then we are trying to say that this region is from minus infinity to minus 4. And here we have from minus 4 to 0, and then here it is from 0 to 1, and this is 1 to 3, and this is from 3 to positive infinity. So these are 1, 2, 3, 4, 5 regions in which the coordinate plane has been divided because of these zeros and vertical asymptotes, correct? Now in each region, what we can do is we can take a test point, right? So we'll take a test point in each. So let's have a test point in this minus 4 to minus infinity. So let's take test point as, let us say, minus 5. Between minus 4 and this, we can take minus 1. 0 to 1, 0.5. 1 to 3 we can take 2, and from 3 to infinity we can take test point of 4. Okay. Now you can plug in these values straight into your function and check whether your value is negative or positive. If it is negative, write negative. If it is positive, write positive. That way you'll know in which region what are negative and what are positive values. That's one way of doing it. And the solution set will be the one in this case, which is negative, right? Because you need to be less than equal to 0. And zeros are included in your solution, not the vertical asymptotes, of course. The other way is write all the factors, which I will show you here. So we'll write all the factors. The number 5 I'll combine with any one of those factors. I'll combine it with x minus 5, right? First factor I will write, which is on my leftmost side, this one. So I'll write x plus 4 first. X plus 4, which gives me this 0 at minus 4. Then the next one is this 0 at x equals 0, that is x squared. I have to write x squared, okay, not just x here, correct? Now this one is at 1, so I'll write 5 times x minus 1 as my factor. So I've included 5 with this. And at 3, the fourth factor, it is x minus 3, right? So I got all my factors which will give me my rational function. Now the step is to test whether it is negative or positive. If I plug in minus 5 here, I get a negative value, which is negative 1, but I'm not interested in 1. I'm interested in whether it's negative or positive. So when I plug in negative 5, I get a negative value, so I write negative here. If I plug in negative 5 here, I get negative 1, so I write negative. If I plug in negative 1, I get a positive value, positive 3, but I write positive here, so I need positive value. How about 0.5? All these positive values will give me positive values. So I'll get positive, positive, and positive. X squared. Now x squared is always positive, whether you write negative 1 or negative 5, right? So these are all positive values for you. Now how about x minus 1? Minus 5 will give me negative value. Minus 1, negative. 0.5 minus 1, since 0.5 is less than minus 1, negative. 2 minus 1, positive, and this is positive. You will see a trend, you see. If you write them in a particular order, you see that trend. That is kind of very important. That's the reason why I wrote them in this order. Now minus 5 will give me negative, negative. 0.5 is less than this. 2 is also less than minus 3, negative. But that will give me 4, right? So I get all the negative positive values for each individual factor. How about my function f of x? So function is actually product of all this, right? Division is also product by its reciprocal, correct? Now either if we have odd number of negatives in our table, then the product will be negative, correct? And that is what we are interested in. So we'll circle those negative things, negative. Here it is even, so it's positive, even, positive, odd number of negatives, negative, right? Even numbers, positive. So these two are our solution sets, right? So we write here our solution to this inequality is, then we can write solution straight from the table, right? Solution is between minus infinity to minus 4. Check if it is a restriction or not. No, there is no restriction here, right? Now when you say less than equal to, you have to include minus 4 also, right? So one of the solution is from minus infinity to minus 4 and you include 4, correct? That is first solution. Union is means and the other solution, right? The other solution for you is from 1 to 3. So we could include both, but 3 is a vertical asymptote at 3. It is not in our domain, and therefore our solution set should be written as, you should include 1, right? Include 1, but you should not include 3. That will be a mistake, right? So there it is. That is why it is very important to list all your restrictions right on the top so that you can always check it, right? So that is our solution. So this rational function is not solved, and we say, well, our answer is, that is a way of writing in interval notation. You also can write in the set form saying x belongs to real numbers where x is less than equal to minus 4. This is one part, and where x is greater than equal to 1 but less than 3. So that could be written in the set form. So like this you can write your answer. At times you may be required to write answer on a number line. So I'll show you that also, answer on a number line. Okay. So on a number line, imagine this is your 0, right? Now your points, solution sets are from minus 4 to infinity, where minus 4 is included. Minus 4 to minus infinity, and minus 4 is included. So we make a filled in hole here and draw an arrow here. So that is at minus 4, correct? The other one is between 1 and 3, where 1 is included, right? So 1 is included, but 3 is not included. So we will make a hole here, right? So this is 1 and this is 3. So that is your answer on a number line, correct? So that ways we can give different answers in different ways. So that is how you solve inequalities. I hope you understand and appreciate the method. Thank you.